So welcome, and today we're going to talk about productivity. And productivity really is a measure of efficiency, and it allows us to evaluate how we are doing, how productively we or efficiently we are using the inputs that we are using. So productivity provides us with a measure of efficiency, and it's calculated very simply. It is, in fact, simply output, units of output per units of input. So frankly, it's that easy. There are a couple of tricks we have to watch out, most notably units, but it gives us a measure of output over input. By itself, a single measure of productivity doesn't tell us a whole lot because there are differences in expectations, there are differences in inputs, there are differences in the quality and of products that we are producing. So what we usually use it for is to compare our performance over time or to evaluate different technologies or different locations to produce the same input. So we'll talk about that through the examples that we're going to do in a minute. There are two different types of productivity measures we can do. There is single factor productivity, which gives us the measure of the efficiency with which we convert individual factors of production into output. So that can be labor, it can be materials, or it can be management. And again, we can do all of those individually if we have measures of those quantities of those that we can evaluate relative to output. Now, we can use different combinations of inputs to achieve the same levels of output. So what we also have is what's called multifactor productivity. And multifactor productivity is essentially a measure where we put for input here, we come up with a measure of, usually in dollars, of all of the inputs we use. So dollars of labor, dollars of materials, and dollars of management to give us a sense of the efficiency with which we are creating output from all of the investments in factors of production. And that allows us to compare different combinations. So let's go, without further ado, to some examples that will highlight both the process of calculation and some of the interpretations that we need to think about. So the first question, let me just share it here quickly. The first question we're going to evaluate is this one, a simple one. Susan has a part-time cottage industry producing seasonal plywood yard ornaments for resale at local craft fairs and bazaars. She currently works 8 hours per day to produce 16 ornaments. What is her productivity is part A. Part B is she thinks that by redesigning the ornaments and switching from use of a wood glue to a hot glue gun, she can increase her total production to 20 ornaments per day. What is her new productivity? And C is what is the percentage increase in productivity? So relatively straightforward question. I would highlight here that we have units of input, 8 hours per day. So we are going to do a labor productivity. And we don't have dollars. So in this case, we are only going to do it in terms of hours. So let's look at question 1 here. A is, so for A, our output was, and you can pause the video and go back and check the parameters of the question if you want, but I'll always highlight them here. 16 ornaments per day. Input was equal to 8 hours per day. And so labor productivity in this circumstance is equal to 16 ornaments over 8 hours equals 2 ornaments per hour. So you always know that you have a productivity or a measure if you have or something per something else, so that it is a rate. It is ornaments per hour. Gives us output divided by the relevant input, output per the relevant input. So our measure of productivity is 2 ornaments per hour. Then with the revised one, output is equal to 20 ornaments. Input remains 8 hours. So our labor productivity is equal to 20 over 8 is equal to 2.5 ornaments per hour. So this is the first point that I would highlight here. We had 2 ornaments per hour. Now we have 2.5 ornaments per hour. When we are using productivity measures, bigger is always better. So productivity has been improved. So there will be times where we do calculations where smaller is better, but in this case, an important point to remember, for students to remember, is that bigger is better. So in this case, we have improved it. Question C was by how much? So we have a percentage increase in production, in productivity, and the percentage change is equal to new versus old over old. This is another mistake students frequently make. Our baseline is where we started from. Sometimes they will use the numerator correctly, but the denominator, they will put new on the bottom. And we always use the point that we started from as the reference point in the denominator. So in this case, we have 2.5 minus 2 divided by 2 is equal to 0.25, or a 25% increase in productivity. So that change that she made led to a 25% increase in productivity, relatively straightforward. We saw how to calculate it, output over input. We saw that it went from 2 to 2.5, which was an increase. We understand that, and we calculated the percentage increase. So let's take the opportunity to look at another question. Question 2 is a similar one, but we'll just review to make sure we know what we're doing. A firm cleans chemical tanks in the Edmonton area with standard equipment. The firm typically cleans 70 chemical tank cars per month. They utilized 20 gallons of solvent, and 2 employees worked 20 days per month, 8 hours a day. The company decided to switch to a larger cleaning machine. Last December, they cleaned 60 cars in only 15 days. They utilized 12 gallons of solvent, and 2 employees worked 6 hours a day. What is their raw material and labor productivity with the standard equipment? What is their raw material and labor productivity with the larger machine? And what is the percentage change in each of these productivity measures? So a very similar question, but in this case, we're doing 2 different measures of productivity. So let's do this one quickly. Question 2, let's start with the standard equipment. We have output equals 70 tank cars. Solvent, or materials in this case, is 10 gallons. And labor is equal to 20 days times 2 employees times 8 hours per day is equal to 320 hours. Now, in this case, we know we could have just done days. We could have done 70 in 20 days, but because we saw in the question that the number of hours worked in a day changed from the first system to the second system, we can't do days because the days aren't the same. And we need to, in order to compare effectively, we need to have consistent measures. It is critical to have consistent units to compare. So in this case, because we saw early that there were 6 hours per day in the second example, we had to change this to hours in order to have an effective comparison. So then we have solvent productivity is equal to 70 cars over 10 gallons equals 7 cars per gallon. So we can clean 7 cars for each gallon of solvent that we have. And for labor productivity, we've got 70 cars divided by 320 hours is equal to 0.22 cars per hour. So almost 1/4 car per hour is our productivity for labor. So then if we move to the second example, the new equipment, we have output equals 60 cars. You can again pause if you need to go back and look at the parameters in the question. Output is 60 cars, solvent was 12 gallons, and labor is 15 days times 2 employees times 6 hours per day. Again, that's why, because it was 6 this time and 8 last time, we're going to use hours, equals 180 hours. So solvent productivity is equal to 60 divided by 12. 60 divided by 12 is equal to 5 tank cars per gallon. So as you can see, previously we had 7. We had a decrease in productivity or efficiency of use of solvent. Because the number got smaller. So now we're going to do labor productivity is equal to 60 divided by 180 is equal to 0.33 cars per hour. When we compare that to 0.22 increase in efficiency of labor. So we know that bigger is better. We can see that we put in consistent units here, and we came up with 2 different measures. The last part of that question was percentage change. I'm just using delta is equal to 5 minus 7 divided by 7 equals negative 0.286, or a decrease of 28.6% in solvent productivity. Percent change labor, I'll just write up here solvent in case you're taking this, in case you're taking notes, is equal to 0.33 minus 0.22 divided by 0.22 equals 0.5, or an increase of 50% in labor productivity. What this doesn't tell us is if we're better off or not. We know the solvent productivity got worse. we know that labor productivity got more expensive, but because we don't have dollar units, it becomes difficult to say whether we're better off overall. So let's introduce the concept of multifactor productivity now. So in order to do that, I'm going to give you a different question. Bear with me here. Question 3 here. A firm makes ceramic vases for a chain of department stores. For a chain of department stores, the output and cost figures over the past 4 weeks are shown in the table below. Labor costs $20 an hour and material costs $8 per kilogram. We can see here units of output increase over the 4 weeks. Number of workers increases over the 4 weeks. Hours worked per week also increases, as does the material in kilograms that we use. It's now asking us to calculate the labor productivity in units per hour for each week, and the percentage change from week 1 to week 4. Calculate the material productivity in units per kilogram for each week, calculate the percentage change, and then calculate the multi-factor productivity. So let's go back to our whiteboard and work through this. So this was question 6, the third question we're doing, and part A, and I'm going to highlight that the question explicitly asked for labor productivity in units per hour. In the absence of that instruction, you could do units per labor dollar and get a right answer. You'd get a different answer, but it would be correct, or units per hour. Given that the question asked explicitly in units per hour, we're going to do that. So labor productivity 1 is equal to 2,000 units, which was the production, and that 4 workers times 40 hours a week. 2,000 units in that week is equal to 12.5 vases per hour. All we did was we took the output, 2,000 for the week, from the table. 4 employees worked 40 hours a week, so we get a total of 160 hours, and then we just simply do the math. We would do the same thing for LP2, 4,000 divided by 4, but this time they worked 48 hours, and we get 20.83 vases per hour. So our productivity improved. For labor hour, we got more vases per hour in the second week. LP3 is equal to 5,000 divided by 5 workers times 56 hours in the week, 17.86 vases per hour. So in week 3, our productivity actually went down relative to week 2, but we're still up relative to week 1. LP4 is equal to 7,000 divided by 6 workers times 70 hours equals 16.67 vases per hour. So you can see there's considerable variability here from week to week, but that overall we've gone up. So let's look at the proportion, percent change. So that would be LP4 minus LP1 over LP1 equals 16.67 minus 12.5 divided by 12.5 equals 0.33, or 33% improvement from week 1 to week 4. Something that's worth noting here that there's significant variability from week to week. That may or may not be bad. Just catching up here. It may warrant some attention. So in this case, it's not just evaluating between different technologies or different approach. It can be used as a measure, a benchmark that you compare week to week. And there might be good reasons. There might have been a breakdown one week. There might have been other factors that affected our productivity. But what it does is it gives us a measure that it won't tell us what went wrong, but to highlight that something is different, and we should maybe take a look, and we may want to investigate So this is one way that productivity can give us a little bit of insight or a hint or at least a red flag to say something's changed, maybe we should take a look. Let's proceed now to B, which was the material productivity. It again asks for units per kg, but otherwise we could do units per dollar of input. So material productivity 1 is equal to 2,000 divided by 128 kgs equals 15.625 vases per kg. MP2 is equal to 4,000 divided by 256 is equal to 15.625, so it hasn't changed. We're converting at the same rate. MP3 equals 5,000 divided by 324 is equal to 15.432 vases per kg. So it's down a little bit, but I would say within the margin of error. So we've calculated all three, and what we see is we're relatively consistent here. We've gone up within sort of a fraction of a vase per kg. I would say some of that is natural variability. Excuse me. And so let's take a look at the percentage change, which would be MP4 minus MP1 over MP1 equals 15.56 minus 15.625 divided by 15.625 is equal to 0.00416, or negative 0, or a decrease of 0.416%. So virtually no change. Now, if we wanted to, and we do because the question asks us to, we can look at all of the factors of production together and do multi-factor productivity. And so for multi-factor productivity, we need to put things into consistent units. So for multi-factor productivity 1, the top is the same. We have 2,000 vases, but now what we need to do is convert the bottom, the denominator, into common units. So to do that, we've got $20 per hour times 4 workers times 40 hours plus $8 a kilo times 128 kilos. So this is labor, and this is material. And in order to be able to do this, we convert them both into dollars so that we have consistent units. You can't just add kilos of material to hours of labor and then divide and get anything that is meaningful at all. So we convert it to dollars, which means we get 0.47 vases per kg. So all we've, per dollar. And so it doesn't matter whether we have labor or material. It means that we have, for every dollar we spend, we get 0.47 vases. So the secret to multi-factor productivity, and it's not a big complex thing, just convert everything into dollars. So multi-factor productivity 2 is equal to 4,000 vases divided by 20 times 4 times 48 plus $8 times 256 kgs is equal to 0.68 vases per dollar. And we do the same thing for the other 2 weeks. 5,000 divided by 20 times 5 times 56 plus $8 times 324, and we get 0.61 vases per dollar. And finally, multi-factor productivity 4 is equal to 7,000 vases divided by $20 times 6 times 70 hours a week plus $8 a kg times 450 kgs equals to 0.58 vases per dollar. So we saw an increase. We saw that same variability that we see in labor productivity went up in week 2 and then came back down again. But then multi-factor productivity growth is equal to MFP4 minus MFP1 over MFP1 equals 0.58 minus 0.47 divided by 0.47 is equal to 0.234, or a 23.4% improvement. So things are getting better. So the last thing I wanted to highlight is a question again that brings into play the units again. So let's take a quick look at the last question. Here it comes. Suppose the workers in Mexico earn 132 pesos per hour. The exchange rate with Canada is 16.5 pesos per dollar. Canadian workers can produce 60 units per hour, while Mexican workers at a similar facility can produce 32 units per hour. If the Canadian wage rate is $30 per hour, should the firm produce in Canada or in Mexico, and why? So this is a real question. This is a real question that companies face. And we can do a direct comparison. But in this case, it makes sense, and in fact is critical, to do productivity measures in units per dollar to reflect not only differences in productivity,
but also the differences in matrix. Make a valid common units comparison. So the real lesson here is not calculating anything any differently. We're just again ensuring we have consistent units. Exclamation mark. The biggest mistake that students make here is not looking at consistent units so that we can do a valid comparison. So let's look at the two countries. Uh, 60 units per hour, so that's the basic. That's the basic productivity, and if you compare it to Mexico at 32 units per hour, you say we're doing better, but let's look at means output, $30 per hour equals input. Divided by 30 equals 2 units per labor dollar. So we get that for every dollar we spend on labor, we get 2 units produced. So now let's look at Mexico. 32 units per hour, 132 pesos per hour in wages, divided by 16.5 pesos per dollar equals $8 per hour. So productivity is 32 divided by 8 equals 4 units per labor dollar. So even though Mexico produces fewer units per hour, because we're paying them less, we're producing more units per dollar of labor that we produce. So this basically highlights that, that we have to have common units. And so based on this, it's going to refer, as I said at the beginning of this discussion, the numbers can give us a sense of input into a decision that can make a decision for us. So in this case, if we were thinking what else would we have to think about in addition to the productivity measures, and there could be a variety of things. I'm sure we could think of more. Material costs is one, shipping costs is another, depending on where our customers are. Tariffs and taxes, labor standards, environmental standards. All of these are important things that could also come into the decision, and so the numbers can give us insight that they can make a decision for us. So that wraps up that quick discussion on productivity, and we reviewed Productivity is a measure of efficiency. Calculate over input. If you remember that you can calculate any measure productivity you want. We have single factor productivity. The choice of recording it form in the starting conditions is that you can sometimes dialogues that are able to eventually or we have paper, material, and management. And we can also calculate multifactor productivity, which considers all or several inputs. And the biggest thing to keep in mind is units matter. If you remember those simple things, productivity will be a straightforward process for you to do, and it should be easy to get through it. Thanks for your time.